Good morning everyone. Today we are going to learn about LEX and YACC program in system software and compiler design. First, we will learn about what is a LEX. A lexical analyzer, also known as a lexer or tokenizer, is an essential component of a compiler or interpreter. Its main purpose is to break down the source code into a sequence of tokens for further processing by the parser. The lexical analysis is the first phase of the compilation process where the input source code is scanned character by character. The lexer groups these characters into meaningful units called tokens, which are the smallest building blocks of a programming language. Tokens can be represent keywords, identifiers, constants, operators, punctuations, symbols, and other language specific constructs. Next, we'll go through the YACC. YACC, for the short for YACC, yet another compiler's compiler, is a parser generator tool commonly used in the construction of a compilers and interpreters. It takes as an input a formal grammar specification and generates a parser code in a target programming language. YACC, it is a typically used in combination with LEX or a similar lexical analyzer generator to create a complete compiler or interpreter system. LEX is responsible for performing the lexical analysis, while YACC handles the syntactic analysis. Means LEX is responsible for performing the lexical analysis, while the YACC handles the syntax analysis. Next, the program for symbol table generator using a LEX and YACC. A LEX and YACC program that scans a source code file and generates a symbol table which stores information about variables, functions, and other identifiers used in the code. Means in the symbol table generator, the LEX and YACC program performs a function as it scans the source code and generates a symbols table, which in symbols tables it includes information about variables, functions, and other identifiers which are used in during the writing of code. Next, coming to the program, first part is the lexer program, where the lexer program begins with percentage into open flower bracket and ends with percentage into closed flower bracket. In between this, include y.tab.h is the command for lexical analyzer, and the rules part. Mainly the lex program contains three parts, where the first part is a definition part, second part is a rules part, and third part is a subroutine part. And the definition starts from percentage open flower bracket and ends with percentage closed bracket. And the code used to the lex program is hash include y.tab.h, and where the rules part begins with double percentage and ends with same the double percentage. In between these, the rules are applied which are required to read the code or the problem. And in last part, the subroutine part is contained. It contains int wrap and return one. Next, coming to the YACC program, it also contains two divisions. First one is the rule part, and second one is the first one is the definition part, and second is the rules part. Where the same here also same as it begins with the percentage open flower bracket, and the definition part closes with closed flower bracket. In between this, the main characteristics are added, like hash include stdio.h, hash include stdlib.h, hash include string.h, and the rules are mentioned where definitions are mentioned, like what the program contains. Struct symbol open flower bracket, it contains as characters names which the input to the program, and struct symbol table 100, int symbol count 0, void add symbol character and name int type, means you should add characters and names as input for the given code. And it also closes with the percentage closed bracket. Then last we should apply, or we should mention what we want to need, like the token identifier. Next, coming to the program statement, it contains identifier number and add symbol s1 and s3 percentage. Then int main means we want to give input, means we should pass the code. Print symbol table, for int I is equal to 0, I less than or equal to symbol count, then I will increase. Then we should print a name as a percentages and type d percentage d. The symbol table I is equals to name and the symbol table I is equals to type. Then we should return to the value 0. Int y error, character and messages. File printf, here f printf means file print f. stderr error, it shows a error if the messages are not correct. Then coming to compile and run the program, follow the steps. What are the steps to be followed to compile and run the given program? First, we need to save the LEXR code in a file named symbol table lex.l. Means we should save the LEXR code in the symbol table lex.l, and we should save the parser code in the file named symbol table yacc.y. And for the parser, for the XML or YACC program, we should use a comment, we should name as a file name as a yacc.y. Then third step is open a terminal and navigate to the directory containing the files. Then third step is we should give a directory where the file should be stored or navigated. And fourth one is to compile the XR and parser using the following commands. And the fourth step includes the commands, which are the commands used to compile and run the YACC and LEX programs. For the LEX programs, it uses the command like lex symbol table lex.l, and for YACC program, it uses a command like yacc.y, or it uses a both at a time like lex.yy.c and ytab.c. And coming to the fifth step, run the generated executable by using a /symbol table. Now you can enter a symbol definitions in the following format like identifier number dot. For the example, my var 1 and another var is 2. After entering the input, the program will generate and display the symbol table. The symbol table is like the displayed symbol table is like name dot my var is equals to type 1 and the name another var is equals to type 2. This is an example that demonstrates how to use LEX and YACC to create a symbol table use generator. It scans the input for the identifiers followed by a number enclosed in curly braces and adds them to the symbol table. Thank you.